We have so far looked at the calculation of the reference feed-forward gain such that the output of the closed-loop system would track a constant reference input with a zero steady-state error, but we have not looked at where this result comes from. In this video, we derive the result. We previously used the results shown here on the left-hand side. Let's quickly recap it. For the state variable plant model and the control law with state feedback and reference input, the reference feed-forward gain N that would cause zero steady-state tracking of a constant reference input R is given by -1 over C times the inverse of A minus BK times B. Let's now look at the derivation of this result. The idea of the derivation is to apply the fact that we look at steady-state conditions to the information specified on the left-hand side, and we manipulate things to arrive at the result. Steady-state conditions mean that the reference input, the states, the plant input, and the output do not change. We assign them the constant values RSS, XSS, USS, and YSS. If the states do not change, the state derivatives are all zero. For zero steady-state tracking, we require the output to be the same as the reference input in steady state. We call this condition equation 1. We now set the steady-state conditions into the state equation and call this equation 2. We set the steady-state conditions into the output equation and call this equation 3. The steady-state conditions applied to the control law gives us this line, which we call equation 4. We have now applied the steady-state conditions to the full system description on the left-hand side. We now combine equations 1 to 4. When we substitute USS in equation 4 into equation 2, we get this line. We now gather the terms containing XSS and left multiply with the inverse of A minus BK, which gives us this line. Here, XSS is the only thing on the left-hand side. This we substitute into equation 3, which gives us this line, and we apply the condition in equation 1 to write YSS as RSS. We now divide by the scalar RSS, which gives us this line. Here we can see that a row vector times a matrix times a column vector is a scalar, so we can divide by the scalar to produce the result we wanted to derive.